Been doing some studying of OAuth 2.0 and OpenID Connect. And if you've been watching any of my videos, you also know that I've been studying encryption a lot out of the parts left to the developer to establish on their own. So I've come up with a recommendation for OAuth 3.0, and it is this. As you know, OAuth involves a so-called client, which is the bird dog and watchdog, or so-called user resource, which could be files or database. And then there's a authorization server out there somewhere. Delegate the authority to authenticate and get authorization information is delegated to a separate service called the authentication server, and that way this server can serve multiple clients, and then you'll use TLS here. So I call this put an AI in there, and you can call this wagging the bird dog and watchdog through its tails. But anyway, I recommend using password-based encryption of this data, user resources, via OAuth to further advance the cause. And so on the authentication server, you'd have a database that would keep both read and write keys, and you can use public key encryption for that. Read and write keys, and they would be encrypted with password-based encryption that end user or resource owner would release with their password. So when the client redirects them to the authentication server, password will be put in there. These will be released and given. It can be given to the client to decrypt for read or encrypt for write based upon those password-based encrypted keys. In this way, certain amounts of security are automatically established. It makes it very difficult with password-based encryption to hijack access to this data to spoof or pose as a resource owner. Almost impossible, basically. And also, it would make data movement around the client and between the client and the user resource less vulnerable because it's encrypted. It's encrypted, and you need these keys to decrypt it. If you add a layer to this, you could also use access control lists. So you'd probably have either an ID or a group ID here, and that could be used in the search key for the data in the databases. And then you'd need these encryption and decryption keys to read and write the data. And this key can be encrypted so that anybody who has DB access can't really associate rows of data together. or to any person if they happen to get a person's so-called ID. They won't be able to match it up with any kind of data in here. And even if they did, it's encrypted anyway, but they could count rows or something like that. Yeah. So you'd also want to use a system encryption of that. So that's an extension of this, some things I've been developing into the realm of the framework of OAuth and OpenID Connect. And so these could be also for OpenID Connect. You're going to use like JWT. So those could be kept in claims of the JWT, and that is, of course, should be encrypted. That'll be encrypted with a secret key from the authentication server, and then it'll be decrypted with the public key owned by. They both have to be secret, but the counterpart key held by the client, and those can be very ephemeral, basically. Yep. We can use another layer of encryption of keys to make it a group rather than a singular.